Today we are going to start the second unit, which is all about introduction to different types of energy. In order to do that, we should probably define a couple of things. First of all, energy is defined as the ability to change or move something. And another thing that we need to define is the system. The system is defined as a portion of space and the objects in that space being investigated or observed, something along those lines. And then lastly, the other thing that we need to define is matter. And matter is any material that has mass and takes up space. So those are the three of the definitions that we're going to be working off of for this unit. Some things to take a look at in terms of comparisons. Both of these cars are 96 Ford Contours, and just by looking at them, hopefully we can identify which one has more energy. The one on the left is sitting still, has a flat tire. The one on the right appears to be moving, so we would identify this one as having more energy because it's moving. Which trampoline appears to have more energy? Well, the one on the right has nobody jumping on it, so it's just kind of hanging out there. The one on the left has a puppy jumping on it, so we could make the assumption that the one with the puppy on it has more energy. And in this case, we have a rock and we have what appears to be some dynamite, and it's got a countdown timer on it. So the question is which one of these has more energy? And the one with the countdown timer, the dynamite, would definitely have some more energy. Now, the thing that we need to keep in track, that we need to keep in mind of, is the fact that even though things have more energy, like in the last few slides, they had different types of energy, and we're going to try to identify those different types of energy during class today. So we also have to talk about how we choose a system. These are two different scenarios. Here is an object at position A, or a human at position A human at position B, a human at position C, and a human at position D. So we are going to choose objects based on the situation. So if we're talking about the fact that the human is jumping off of a tower with a bungee cord wrapped around him, well, and we said that the human was the system, we'd be focusing on how energy is being tracked in relation to the human. If we were talking about the bungee cord, we would talk about how energy is being tracked in relation to just the bungee cord. Over here we have a person on a skateboard, and that person on a skateboard appears to be at the top of a ramp or a half pipe, and that person is, if we say he's the system, we are going to keep track of how he's moving and how energy changes with him. So the first law of thermodynamics is another thing that we need to kind of keep in mind, especially in this unit. And the first law of thermodynamics is defined as the total energy in a system. Like the total energy of the human jumping with a bungee cord wrapped around him, or the skateboarder in the last slide. So the total energy of a system is constant and energy can be transformed from one form to another, but energy cannot be created or destroyed. So the thing of it is that when we're looking at a system, we're talking about how much energy is at the beginning of the scenario and how much energy is at the end of the scenario. They have to be equal to one another, or if they're not, we have to be able to keep track of where that energy started and where that energy ended up. So sometimes the energy might leave the system, sometimes the energy might be added to the system, and we'll learn how to deal with that more and more and more through the course of this unit. There are a couple of other things that we need to define. One of them is kinetic energy. Kinetic energy is defined as the energy of motion. A couple of things to keep in mind is that faster objects, that was silly, have more kinetic energy. And more massive objects have more kinetic energy. Now, when I'm saying that more massive objects, I'm talking about larger objects in comparison. So if I'm talking about this rock versus this rock, and they're both traveling and they both are moving, this one would have more kinetic energy just because it's bigger. Another type of energy that we have to keep track of is something called thermal energy. And thermal energy is the energy of particle motion. And a few things to keep track of there is that the more particle motion gives forth more thermal energy. We often think of thermal energy as heat energy. It's not limited to that, but that's one of the things that it's easier to think about. With thermal energy, it's difficult to convert to other forms of energy. Simply because we're talking about particle movement here, and keeping track of particle movement and changing it to some other type of form is a little bit difficult. Another thing that we really want to keep focus on here is sometimes thermal energy is also called dissipated energy. Okay, and we'll come back to that later on this week. And then another thing that we need to define is potential energy, and potential energy is simply energy stored in an object. In an object because of its position. Or what it's made up of. Okay, so given these two scenarios down here, I have a ball at the bottom of a pit, what appears, or bottom of a ramp or a half pipe, and I have a ball sitting on top of a hill. So this might be a ball in a valley. Oops. And this would be a ball on a hill. And the question is, which ball has greater potential to move? Hopefully you would identify the ball on top of the hill would have greater potential to move because it can roll down a hill, and hopefully you know that rolling down a hill is easier than going up a hill. And then the other thing that we need to talk about is the different types of potential energy. And there are 5 of them that we are going to keep track of throughout the course of this unit and the semester. One of them is if you have a ball on top of something and it's going to fall, or an object on top of something that's going to fall, we call that gravitational potential energy. Sometimes we might have a spring or something elastic and it's really, really coiled tightly or stretched apart, and we would call that spring or elastic energy, potential energy. Another type of potential energy is chemical potential energy, in which case you might have some type of a fuel that will burn, that will make an object move, or you'll eat food and that food will become the fuel that drives your body to do things. Another type of potential energy is electrical. And electrical potential energy we might keep track of like in a battery. So if you have a battery sitting on a table and it's fully charged, it has potential energy in it, but it hasn't done anything yet. And then the other type that we're going to keep track of is atomic energy. And that's simply going to be talking about the energy of the parts that make up atoms. And we'll get more involved in that a little bit later. So your homework for the evening is going to be working on worksheet number 1, which is about identifying different types of potential energy. And we'll go through that in class tomorrow.